Okay, this is basically an addendum to the previous video. It was long enough as is. So the video was, as you recall, we showed that the limit as theta goes to 0, sine theta over theta is equal to 1. We did by the squeeze theorem, squeezing between cosine theta and 1. That video was long enough as is. I wanted to emphasize the main points. This video is just going to hit some leftovers from that video. So the first thing is that you had to know that we were doing here, theta was bounded between minus pi over 2 and pi over 2. If you were paying close attention, our pictures were drawn in such a way that theta is between 0 and pi over 2. We're in the first quadrant. So if you take a look at the textbook, it can walk you through a little bit and say, okay, this very much goes through analogously if theta is between negative pi over 2 and 0. So I'm going to omit those details. Suffice to say, things go through pretty much in the same way. This is the important thing. The second thing I wanted to talk about is that I kind of glossed over the whole, why is this distance right here tangent theta? So let me just redraw that. So here is cosine theta, sine theta, and so if we draw this out here, oops, that's a horrible picture. Let's try that again. So here is cosine theta, sine theta, and this is, of course, 1, 0, and so we use the fact that this is tangent theta. How can we argue that? Well, note that we have this line right here has slope equal to, well, it goes through the point 0, 0, and cosine theta, sine theta. So the slope is sine theta minus 0 over cosine theta minus 0. Oh, look, the slope of that line is exactly tangent theta. And here we have a triangle where slope is rise over run. So the run is 1. And the rise is, well, going to have to be tangent theta. So that's how we can argue that. That's the glossed over detail from the previous video where that height is tangent theta. The third thing to talk about is that there's actually a second important squeeze theorem limit. So there's two important trig limits. The first is, well, the one that we just have. The limit as theta goes to 0, sine theta over theta is equal to 1. And the second one is the limit as theta goes to 0 of 1 minus cosine theta over theta is equal to 0. So these are our two important trig limits that are non-trivial. Take a look at this one. 1 minus, well, as cosine theta goes to 0, as theta goes to 0, cosine theta goes to 1. So we have a 0. So right now, this is a 0 over 0 indeterminate form. And so we have to do something with it. As it turns out, the easiest way to prove that this does equal 0, of course, you could do it with you could try to get some intuitive sense that it's equal to 0 by graphing it or by plotting points and stuff like that. But in order to prove that equals 0, the best way to do it is by using this fact that we just did. So we can prove this. Limit as theta goes to 0, 1 minus cosine theta over theta equals 0. We can do it with the following system of manipulations. So we start off with limit as theta goes to 0 of 1 minus cosine theta over theta. And we're going to multiply by the same thing on the top and the bottom. So limit as theta goes to 0, we're going to multiply both the top and bottom by 1 plus cosine theta. So 1 minus cosine theta over theta. So why do we do this? Well, the numerator, 1 plus cosine theta times 1 minus cosine theta, that's a difference of 2 squares. That's the limit of 1. So the numerator is 1 squared is 1 minus cosine squared theta and we'll leave the denominator untouched. Okay, so that is 1 minus cosine squared theta. That square is in the exponent there. And take a second, why do we want 1 minus cosine squared theta? Trig identity, sine squared theta, cosine squared theta is equal to 1. So 1 minus cosine squared theta, that manipulates to sine squared theta over 1 plus cosine theta times theta. Okay, so at this point, we have 2 factors of sine theta in the numerator, and we have 2 factors in the denominator. So let's rewrite that as sine theta over 1 plus cosine theta times sine theta over theta. And at this point, we would like to be able to use the product rule. So we'd like to be able to say the limit of this times this is the limit of this times the limit of this. We're justified in saying that if both this limit and this limit exist. So let me write this out, and then we'll see that yes, those 2 limits do exist. So one of them is real easy. We just spent an entire video showing that that limit is 1. And how about this limit? So as theta goes to 0, sine theta goes to 0, cosine theta goes to 1, and so we're left with 0 over 2. Yeah, this is fine. We don't run into any trouble spots. We're not in a 0, 0 indeterminate form. We're not in something that doesn't exist. So this limit is 0 over 2, or just 0. So what do we have? 0 times 1 is equal to 0. So chasing all of this back from the start. So we start with 1 minus cosine theta over theta, the limit as theta goes to 0. We introduce this extra factor to rewrite this as sine squared. We had 2 factors in the denominator, so we broke this up as 2 separate factors, that each of these we can evaluate the limit. So we're using the product law. 0 times 1 is equal to 0. So that takes care of, now we have a fundamental trig limit for 1 for sine and 1 for cosine.